For this lesson, we're going to start outcome 7C, which is demonstrating understanding of sinusoidal functions. So what we need to be able to do is match equations of sinusoidal functions to their corresponding graphs and determine, using technology, so the graphing calculators, the sinusoidal function that best approximates data. So today we're going to look at the graphs of sinusoidal functions and identify characteristics of those graphs. So first of all, a periodic function is a function whose graph repeats in regular intervals or cycles. So these first two graphs here, we see that the pattern is repeating over and over. A sinusoidal function is any periodic function whose graph has the same shape as that of y equals sine x. So the first two graphs, this one and this one, are both sine graphs. And we know they are a sine graph because they start out at y equals 0. The second two graphs are also periodic functions, and they're also sinusoidal functions, even though they're described by y equals cos x. The difference is it will start out y equals 1 instead of y equals 0. So it's still a repeating pattern over and over. Each graph will have a midline, and that's the horizontal line halfway between the maximum and the minimum values of the periodic function. So if we have our max here and our min here, the line runs exactly between those 2 points. The period is the length of the domain to complete one full cycle. So if we started here at the origin, one full cycle would be going up to the max, down to the min, and then back to that starting point at the midline. That would be one full cycle. A period can start at the max, go down to the min, and then back up to the max. Doesn't matter where you start, as long as you come back to that original starting position. And the amplitude is the distance from the midline to either the maximum or the minimum value of the periodic function. The amplitude is always expressed as a positive number. So it's basically describing how tall is the sine wave. So from the midline, how tall or how high does it go or how low does it go, but we always express it as a positive value. In this outcome, you'll also see something called radian measure. It's the measure of the central angle of a circle subtended by an arc that is the same length as the radius of the circle. So if we have this angle theta, the arc that subtends that central angle goes from A to B, and that distance is the same as the radius. You can see by these lines. Okay, so that angle, theta, equals 1. Angles can be measured using different units, and these can include degrees, which you're familiar with, radians, which we're going to see in this outcome, gradients, and minutes and seconds. Any angle measures presented as real numbers without units are considered to be in radians. So just a little bit about radian measure. It is an alternative way to express the size of an angle. Using radians will allow you to express the measure of an angle as a real number without units. The central angle formed by one complete revolution in a circle is 360 degrees or 2 pi in radian measure. In radian measure, 1 is equivalent to about 60 degrees, so approximately 60 degrees, not exactly. Pi is equivalent to 180 degrees, and 2 pi is equivalent to 360. So we know that a full circle makes 360 degrees. So if we have that symbol degrees, we can also describe it as 2 pi. So we're just going to look at some characteristics of sinusoidal functions on the graph. We want to be able to describe the graph by determining the range, the equation of the midline, the amplitude, and the period. So the range still describes the y values. So basically we want to describe what values are allowed for y, and this is going to be restricted by the max value and the min value. So our max point is here, which is at y equals 2. Our min point will be at y equals negative 4. So we can say that the range is between negative 4 and positive 2. So you can use interval notation, and we would use a square bracket because those values are included. The graph passes through the min point and the max point. Or we can use set notation. So we can say y such that negative 4 is less than or equal to y is less than or equal to 2, and y is a real number. So that just says that the y values are between negative 4 and 2. The equation of the midline is going to be an equation. Since it's going to be a horizontal line, it's a y equals line. So the midline will always pass through the y-axis. So we need to be able to find out what that is. The midline will be the average of the maximum and minimum values. So we can take those values, 2 plus negative 4 divided by 2. So that would be negative 2 divided by 2 equals negative 1. So our midline is the line that is passing through y equals negative 1. And we can just double check that to make sure that it actually is the same distance away from the max and the min. So we would count 1, 2, 3 up to the max, and down 1, 2, 3 to the min. So it's exactly in the middle. We want to write it as an equation, so the equation of the midline is y equals negative 1. We also want to find the amplitude. So that's, remember, the distance from the midline to the max or the min. And we just counted that, so it's 1, 2, 3 to the max. So amplitude equals 3. We express it as a positive value. And the last characteristic would be the period. So we want to describe how long does it take to complete one full cycle. So this first graph actually doesn't give us a full cycle on the graph. So we can go from the max point down to the min, and then we'll double it because it would end up off the graph. We want to go, if we're starting at this max point, we want to go all the way down and back up to the max point on the next period. So it's going from 1.25 right here to 3.75. So let's find that distance first. That would be half of the period, so then we're going to double it. So 2 times 2.5 equals 5. So that means it would end up somewhere right here. Oh, up here somewhere. Okay, for part B, same characteristics. So the range, again, we want to look at the max and min value. So our max is at 7. And the min is at negative 3. So we'll just do it in interval notation. The values are between negative 3 inclusive to 7 inclusive. And the equation of the midline, again, we can use our max and min values to find this. You can also just count on the graph if you want. So we'd have 7 plus negative 3 divided by 2. We want to know the average, so halfway between. So that would be 4 over 2 equals 2. So that means that midline is passing through y equals 2. And we'll just double check. 1, 2, 3, 4, 5, up to the max. 1, 2, 3, 4, 5, down to the min. And then we'll write it as y equals 2. For the amplitude, we just counted that, so it's the distance from the midline up, which is 5. and the period. This one has several repeated cycles, so we can just go from one. You can start either at a midpoint or at a max or a min. Doesn't matter. So we want to find a spot that lines up nicely with the numbers on the x-axis. So we'll start here at this midpoint. It's at 180. Oops, this is kind of offline here. So starting at 180, a complete period would go all the way up and then back to that point where we started. So at the next min point would be at 360. So the distance between 180 to 360 is 180. So the period, complete one full cycle, is 180 degrees. For this next example, we want to sketch a possible graph of a sinusoidal function with the following set of characteristics. So our domain tells us that it's going from 0 to 180 degrees. The range is 2 to 6, so that tells us a lot of information. Our period is 90 degrees, and the y-intercept is 4. So let's just put our intervals on here. So since we know that the graph is going from 0, we'll start at the origin up to 180. We can make the end 180. Halfway would be 90. And then we can just divide those two portions. So 45. And then between 90 and 180 would be 135. So we know that our min is going to be at 2. Our max is at 6. The range tells us that. So the highest point will be 6, the lowest point will be 2. So we can find our midline, which will be right in between there. So 4 will be our midline. I'm just going to draw a line there to help us when we are creating the curve. The y-intercept is 4, so we know that that's our starting point. So it starts at the y-axis at the midpoint. So now we have to use the period of 90 degrees to show that it's going to complete one full cycle. So it's going to go all the way up to the max, down to the min, and then back to the midpoint at 90. So we know that we have to end up here at 90. And same thing from 90 to 180. So we're going to be here. Since 45 is exactly between 0 and 90, we know that the wave will also cross at that point. And same with 135, it will cross here. So all these points that I've drawn on the midline, our wave will pass through. So between 0 and 45, we're going to go up to the max, so about there. And then between 45 and 90, down to the min. Right about there. And there. So now we can join these points and sketch our wave. Oops. So there we can see the period. It starts at the midpoint, going up, down, and back to the midpoint. So this graph gives us 2 full periods. You can determine the characteristics of a sinusoidal function from the graph. The period is the horizontal distance between consecutive maximum values or consecutive minimum values. It's also twice the horizontal distance between a max and a min value in the next, between a max and a min value. The equation of the midline is the average of the max and the min values. The amplitude is the positive vertical distance between the midline and either a maximum or a minimum value. It is also half of the vertical distance between a max value and a min value. So now you can do practice 1 in your textbook, or if you're doing this course through CEC, practice 1 in the back of your booklet.